We live in a world where we need access to electricity and energy in ever-increasing measure. South Africa is blessed, and especially so with renewable energy resources. The sun, the ocean, rivers, wind, and biomass. New technologies are demonstrated across the country, with Stellenbosch paving the way for South Africa to be recognized as a major contributor globally.
The National Department of Science and Technology placed a responsibility on Stellenbosch University to host a postgraduate program in renewable and sustainable energy studies. This is a hub and spoke model. The spokes are the different research groups in the university, including a research chair in biofuels, as well as spokes in solar thermal, solar PV and wind energy that we share with other universities. Over the years, Stellenbosch University has made a large contribution to the development of human capital, the generation of knowledge and the transfer of technology in renewable energy.
During 2012, Stellenbosch University signed a contract with Eskom, the National Electricity Utility Company of South Africa, to become the specialization center in renewable energy technology.
The Centre acts as a facilitator of renewable and sustainable energy studies at Stellenbosch University and across many other South African academic institutions. Various postgraduate degrees are supported, both coursework and research master degrees as well as doctoral degrees. The postgraduate courses are offered on the campuses of Stellenbosch University and the Sustainability Institute through a partnership between the faculties of engineering and economic and management sciences, and specifically through the Sustainable Development Program of the School of Public Leadership. However, students from other South African academic institutions are allowed to enroll for the courses free of charge to obtain the credits for their respective degrees at their host institutions.
The unique research facilities at Stellenbosch allow for a diverse range of research projects to be undertaken.
My undergraduate project looked at developing a mathematical model for an oscillating water column, which is one of the devices used to harness wave energy.
My doktersgraad in golfenergie navorsing, waarin ek gedetailleerde ontwerp gedoen het van 'n golfenergie-omsetter wat in 'n breekwaterstruktuur ingebou is wat tipies is vir 'n haweontwikkeling. Verder het ek ook 'n ontwerp gedoen van die stelsel vir 'n spesifieke site in Tafelbaai en ek het gevind dat Granger Bay die mees ideaalste site is vir hierdie toestel.
My master's thesis shifts focus to ocean current energy with close examination of the Agulhas current. The Agulhas current is a valuable resource which is currently untapped in South Africa.
My research focuses on concentrating solar power, specifically on heliostat tracking control. So a heliostat is a slightly concave mirror that we use to reflect solar energy onto a boiler located at the top of a tower. In large power plants, these heliostats are typically located hundreds of meters away from your receiver. Tracking accuracy is very important. So we've developed a combined open and closed loop control system, which basically uses software to correct for mechanical errors. So this will allow us to reduce our mechanical and installation tolerance requirements, which can lead to lower cost heliostats.
My research is focused on thermal storage for packed beds in solar power plants, and what we've particularly been looking for is a cost-effective way for storing heat energy. The reason this is necessary is because the sun doesn't shine at night, and in a solar power plant it's still necessary to generate electricity then. So what you do is you store the heat during the day and then use it at night. What we've been looking at is using packed beds of rock for this application.
Our initial analysis showed that the OCGT systems generate energy in excess of 5 rands per kilowatt hour, which is higher than the energy generation capacity of the CSP system, which is just less than 2 rands a kilowatt hour. My research was thus about investigating the feasibility of utilizing CSP plants as peaking stations in South Africa.
I've had the opportunity to complete a number of short courses I've worked with the Stellenbosch University ISHAC team in installing home solar systems in the Enkanini informal settlement in Stellenbosch. In addition to all the project work that I am involved in at the center, I have also been given an individual design project.
The focus of my studies is on the improvement of the electrical generator part of wind turbine systems. This is achieved by more special attention given to the optimization of direct drive permanent magnet machine topologies. A central theme also throughout my research is on a new type of wind generator, which we call the slip synchronous permanent magnet generator. This generator is different to conventional systems due to the fact that it requires no gearbox or power electronic converters, which significantly increases your reliability and reduces the operation and maintenance cost of wind turbine systems.
I'm doing my master's in mechanical engineering, specializing in rural electrification with renewable energies. Specifically, I'm working on a concept called the solar turtle. What the solar turtle is, it's a battery charging station business that you can deploy in rural communities to give instant electrification. How it works more or less, you take a second-hand shipping container and you turn it into a battery charging station. All the PV panels and so forth on the inside. In the mornings, the solar turtle opens up and the panels deploy outside, charging the batteries on the inside. In the evening, when the batteries are charged, the community visits the solar turtle and swap out their flat batteries for full ones, which they can then take home to power small appliances like TVs and so forth.
My work focused on producing second-generation bioethanol from renewable materials, specifically sweet sorghum bagasse. My focus was on combining the enzymatic hydrolysis step and the fermentation steps into a single process in a single reactor to reduce the capital costs so we can produce the ethanol more economically. The end product that we're hoping to achieve is to produce enough ethanol that we can supplement our fuel supplies, specifically use a 10% ethanol blend in petrol so that we can use that in our cars.
Energy technology assessment is inherently a complex process that requires inter- and transdisciplinary approaches. My PhD study developed a framework that is known as Systems Approach Technology Sustainability Assessment that was applied in the biodiesel production development in South Africa. The study showed that there is need to take into account of combined strategies, including government support in form of subsidies, taking into account of the community perception to grow crops for biodiesel production, and for the investors to make use of the waste that comes out of their production as part of their investment portfolio.
A number of short courses in renewable and sustainable energy are offered during the year or are tailored for specific clients.
We also have a very successful schools program where we have developed learning material for learners that can be downloaded from our website.
The Centre has a team of competent engineers and project managers that undertake contract research for clients on renewable solutions. The Centre is also well positioned to assemble expertise from the broader university community and private consultants to participate in multidisciplinary projects.